Hi guys, in this video we are going to learn another interesting question from the series RLC circuit, which is connected in series. Also they have given the values of RLC and they are asking about the impedance of that circuit in the Cartesian form as well as the polar form. If you are new to this expert tutor channel, don't forget to subscribe it. Also we have already discussed this question to change the the impedance form from Cartesian to polar. Also we have learned how to change anything from polar to Cartesian forms. So here the new thing is we need to find the total impedance of a series of circuit when they are giving the values of RLC over here. Also they have mentioned the voltage source they are providing for this circuit. So first of all, you can directly apply this equation when the RLC are in the series circuit. Sometimes you might think, what's this and how we derive this for our need. So the question over here is whether you can use this equation directly in your exam. Yes, you can use it directly according to their question. So let's prove this one easily. Let's say there is an R over here and there is an impedance, the inductor, and after that let's say there is a capacitor. So this is C. So if they are in the series, we can directly tell when we are considering about the I, the current, it's going to be the same for these three. As they are in the series, if it's passed through the R resistor, it's going to be the same for inductor as well as capacitor. So the question over here is, what's the difference of this voltage? Let's say this is VR and this is VL and this is going to be VC. For this one, we can directly write it's going to be the VR is going to be, as we already knew the equation, V is equals to I into Z, the impedance of that element. So when you are considering about the current, it's going to be I and the real part is going to be the R and plus 0J. Hopefully you can easily understand this. This is because we can directly tell this is going to be the impedance, the real part of this impedance, which is the resistance. And when we are considering about the resistor, we actually knew that the reactance part is going to be 0. Likewise, we can directly write it's going to be I into 0 plus, we can tell the reactance of this impedance would be omega L. So it's going to be I into omega. So don't mistake me, it's going to be VC plus VL. Let's take the total sum. So the VR is going to be like this one. So likewise, we can directly tell I into for the C1, we can directly write it's going to be 0. Be careful, it's going to be minus 1 over, let's say this is J, and minus 1 over omega L into G. So this is the equation. If I take the total, it's going to be voltage of these three, the voltage difference across these three, and if I use this I, it's going to be, if I take the common I, it's going to be I, and we can tell the impedance part would be R plus, if I take this J common over here in these two, it's going to be omega L minus 1 over omega C into J, which simply means it's going to return a function like V into I, the Z of these three elements. So it's going to be R plus omega L 1 over omega C into J. So the question over here is, we can directly write this Z would be the magnitude of this Z can be written like this one. If they have given the value in a complex number form, as you can see here, this is a Cartesian form, I plus J, like this one. So this is the real part and J is the complex number part. If we consider like this one, we can directly tell that Z is going to be equal to the magnitude of Z will be root of R squared, this part, plus omega L minus 1 over omega C, taking the, so we need to square it and we need to take the whole root. So actually you can directly use this equation. The another important thing is, actually we need the value of R over here. We can directly substitute the value of 15, and after that we can take the omega from this equation. As you can see over here, it's going to be 1000, the omega is going to be 1000 radian per second. If I write it like this one, we can directly tell that is going to be root of r squared, which is 15 squared plus 1000 into L, which is 0.1. And if I deduct the part 1 over 1000, be careful with the C, it's going to be microwave, so 12 into 10 to the power minus 6 into squared. So we need to simplify this. Either you can use your manual method or you can use calculator to solve this. If you solve this, you are going to get a value. Let's say this is 15 squared, it's going to be 100 minus, if I solve this, it's going to be 10 to the power minus 3000 over 12 whole thing squared. So if I simplify a little bit further, I'm going to get plus 1200 200 over 12. So we can write it like 200 over 12 divided by 4, 50 by 3 whole thing squared. So if we simplify this, we are going to get the value for that z. Be careful, we are going to get the magnitude of this z. When you are considering the magnitude, what can we directly say is, if we find the mod of z, is going to return the value of the polar form. When we are considering the polar form of this impedance, we actually knew that it's going to return the magnitude of this part. The magnitude is going to be the z mod of z, let's say mod of z, and with that we need to give the respective phase angle for this z. For finding the phase angle, we can directly use the equation, which is tan phi would be equals to omega L minus 1 over omega C over R. So if we substitute over here, you will be getting the answer. And the main thing is, you can get the Cartesian form by substituting the values for in this equation. The R, the real part, is going to be 50, and another part, the plus, is omega L 1000 into the L part is 0.1, and if you substitute this, you are going to get Z would be equals to 15 plus J into 16.67 ohm. Likewise, you can solve this part and get the answer. Otherwise, you can directly use the calculator and get the answer easily. So this is a method we are going to we have discussed in this question. If you have any suggestions or if you have any doubts, please comment it below. Thank you.